Hello. I recently watched some YouTube videos in which some math YouTubers told other people about their mega favorite numbers, which is the your favorite number over 1 million. And so I began to wonder, what is my mega favorite number? If you want to watch all the video, just search for hashtag MegaFavNumbers and you'll get the playlist with all the videos. This started with Singing Banana and also other famous math YouTubers. Here you see the first three videos I saw about this mega favorite numbers thing, and I like them really much. So just go and check them. But then I asked myself, what is my favorite number over 1 million? I don't even have a favorite number, a small favorite number. So it's a very difficult question to me. And so since I'm in very into math and Disney comics, I talked about some very huge number appearing in Disney comics. And for example, what is the total amount of money owned by Uncle Scrooge? And here you see in a story of Barks where Scrooge learns about his money, and there are some strange number as obs 20 million, which is a very strange and made up number. So it may be not a good idea to find that. But actually, you can see that somewhere else, Barks tells us that if Scrooge continues losing $1 billion a minute, he will broke in 600 years. And so you can calculate using this fact his exact amount of money. Since it's $1 billion per minute, there are 60 minutes in an hour and 24 hours in a day, and approximately 365.25 days a year, and there are 600 years in which you will get broke. Then you'll get that huge amount of money. But actually, that is just a made up number. It's not really interesting per se. So I did what I usually do when I start studying some problems about huge numbers. I begin to talk about the smallest of them to see if I can see some pattern. And so I just asked myself, well, there are some interesting mega numbers and I want to find the smallest of them. There are YouTubers much better than me, but I want to be the one who finds the smallest interesting mega number. And so to find that, I began to think about the interesting numbers, no matter if they are over 1 million. So I just began, starting thinking about numbers and their properties and seeing if they are interesting or not, just to find some idea. And so the number 0 is interesting because it has the property that any number times 0 makes 0 itself. So it's interesting. And the number 1, well, any number times 1 makes the number itself. So 1, it's quite interesting. And 2, well, 2 is the only even prime, so it's interesting. And 3, well, 3 is the first non-trivial triangular number. Of course, also 1 is a triangular number. So it's interesting. And 4, it's of course the first non-trivial square number, and it's interesting. 5, well, 5 it's the only number which is in two twin prime set. It's in the set of twin prime 3 and 5, and in the set of twin prime 5 and 7. There are no other of this kind because of every 3 odd numbers in a row, at least one is a multiple of 3. And so they cannot all be primes, except if the one multiple of 3 is 3 itself. So 5 it's interesting. And 6 is the first perfect number. Not only 1 plus 2 plus 3 makes 6, and 1 times 2 times 3 makes 6. Quite interesting. And so you can go on, and probably you'll find some nice properties about 7, 8, 9, and so on. So, well, my idea of starting with small numbers and that does not give you idea, because you can see that the properties are quite different from one another. And so it's quite different to define precisely what is interesting and what is not interesting. But let's take another kind of look. Are there non-interesting numbers? All the small ones seems to be interesting for some way or another. So are there non-interesting numbers? Well, let's say n is the smallest non-interesting number. So n, we say that is not interesting. So it's interesting? No. But it has some property. Well, yes, it's the smallest non-interesting number, as we said. And so, is it interesting? Well, yes, it's the smallest non-interesting number. That's very, very interesting. And so, actually, that's a contradiction. So, what does it mean? It means that this n, the smallest non-interesting number, actually does not exist. And so, all numbers are interesting. And since we were interested in the smallest interesting number over 1 million, and all numbers are interesting, we are just interested in the smallest number over 1 million, and that is 1,000,001. So my mega favorite number is 1,000,001. And if you're interested in such logic and paradoxical reasoning, well, I can say that you should check Logic Comics, which is a wonderful comics about the history of logic and about Bertrand Russell and all this kind of paradoxes. Well, and I really like my mega favorite number 1,001, but I have to say that after I made this presentation, I decided to go and check if I was the only one having this idea, and unluckily I was not. James Stanton had the very same idea and is probably much better than me and saying things, so go check his video. But I stand for my mega favorite number 1,000,001. All numbers are interesting.